Okay, so welcome back to yet another training session for the Kepler database project for stellar variability. In this short little film, we're going to discuss a star that is quasi-periodic. That is not very periodic, not extremely periodic, but maybe potentially periodic. The star is actually number 3116348, and I've already brought up its information in the NASA Exoplanet Archive database here for you. And I'm going to click on the View All Time Series and Periodogram link after I take a quick look over here at something interesting. Just for your edification, it is a type G star. It has a surface temperature of about 5,500 kelvins, so it's very sun-like. Well, until you look at the time series of its photometry. Once again, when Kepler database comes up, it gives you the 0-quarter plot. Uncheck that and check the Q3 long cadence checkbox here so that you can update the plot now, clicking update plot, and it gives you the latest and greatest. And lo and behold, look at that thing. This is not very sun-like after all, is it? It is variable, definitely. The thing is going up and down considerably and is pretty messy looking. You can also see here that there are a couple of spots where the spacecraft has not properly recorded data, probably because it was in maintenance mode or something like that, but not to worry, it's not going to injure our research at all. So let's see if this is periodic. You kind of get a hint that perhaps there's some periodicity here. It sure isn't the most beautiful thing, but let's scroll down a little bit and have the software compute a periodogram. And this will take some time. The more complicated the light curve, the more time it takes to do a fast Fourier transform on the information. So here we have a periodogram for our star. And you can see that it does have one large peak, but the peak is very wide. It's not thin, which is what we're after. Remember, a thin peak tells us that there is a very high probability that the period it is calculated is correct. Here, there's quite a wide range for this peak, from left to right, somewhere between the order of like 15 and 16.8 days, 16 or maybe even 17 days. See, here is 10 to the 1, and here's 10 squared, 100 days, so this is right around 15 days, and so here it is, 15.8 is the center of this peak. Okay, so is it periodic? Well, maybe. Let's take a look at the folded light curve using the period of 15.8 days. And sure enough, it looks like it's got some pulsation going on. But look, it's a little bit funky. There's a dip in the middle there. There are a couple of lower dips at the bottom, which indicate that it hasn't quite bottomed out in terms of brightness. It is not a regular pulsating star. So if you think that it's regularly pulsating, you'd expect the light curve to go from one extreme, bright, to the other extreme, faint, and repeat, lather, rinse, repeat, right? And it's going to pulsate in and out smoothly. This is not doing that smoothly. And you can certainly go back here and look at the light curve over time. You can see that the star's brightness is changing, but it is not exactly a smooth pulsating thing. So we'll call this quasi-periodic. It's not completely non-periodic. In other words, it's not a non-periodic star. We'll show you one of those next, but it's definitely a quasi-periodic star. And you can thank your lucky stars that we don't orbit this one, because humanity would be in deep trouble. Thank you for watching.